Hello, here we go. Let's talk about resistance. Resistance, as you have seen my other videos concerning Ohm's law, try Diaz, Diaz, and go to YouTube, type that up, okay? You'll see what I'm talking about. Resistance. Resistance very important, especially when you have like all these wires here, different type of wires. You got round wires, square wires, all type. It could be a metal. And you want to measure the resistance. Let's take for instance this cable right here. Solid wire, could be 36 gauge, could be 12 gauge for electrical in the house, or 10 gauge. But the most important thing to understand is that when you are using a wire, you want to know the resistance of it. Could be the different type of wire. Here's the type of material. Resistivity, constant of different metals. And don't forget, this is at temperature 68 degrees Fahrenheit, or you could say 20 degrees Celsius. Some are 25 degrees Celsius, so it does vary. The ohms per mil per foot varies, which is a K constant that we're going to talk about. We're going to talk about copper, which is 10.4. Sometimes copper at a different temperature, like at 25 degrees Celsius, 25, not 20, it's going to be like 10.57270, something around there. It's going to be higher. The higher the temperature, the higher the ohm value, because resistance go up. Okay, if it's colder temperature, it'll go down. So we're doing this at 20 degrees Celsius, which is 68 degrees Fahrenheit. Now, how did we get this value, like 10.4? The way to get that value, the constant K, is by taking 1 foot of wire. 1 foot, that's the length. And then what they do is they take 1 mil. 1 mil equals to 1/1000th of an inch. That is very, very, very small. Very small. So what we got here, this is how it's determined for all different type of materials. And we'll continue here, okay? Now let me explain to you something very, very clear, that a square mil, the cross-section area of the wire has 625 circular mil, but only 490.625 square mil. Therefore, a circular mil represents a smaller unit of area than the square mil. As you can see here, look at the graph. Circle, a perfect square, it's like cutting away. You can see all that in here. That I don't have to explain to you. That you could see it in graph C here from this figure 1.2. It's a comparison that you can see. So it depends what type of wire you use. It could be a long piece of copper wire that's square that you're using. You want to know the resistance on it. Then you use different formulas on it. As you can see, we're going to use this type here, which is A equals to D square on our chart, okay? For circular, here's A equals pi times R square, the radius square. As you can see all this example here. I'll let you read all this here since we don't have too much time on the video. I'm giving you an example, a problem, and a solution. Okay? Let's keep going. If you have to stop the video, stop it, pause it, or and read it and research it. Now this is the formula we're going to use here. Here it says formula, it's R, which is resistance, equals K times L divided by D2, D square, which is the diameter square. Now, if we know the K is what we were talking about, the 10.4 up there, remember? K is a constant, which is the resistance of a mil foot of wire. Remember that 1 foot of wire that we talked about? 1/1000th of an inch? A mil foot is a section of wire having a diameter of 1 mil. It's 1/1000th of an inch. And the length of 1 foot. That we know. Now L is going to be this is the length of wire in feet. Like we're going to use about 12 foot as an example later on. That's where you put that 12 foot in there, okay? You're going to put 10.4 here, 10.4 here, okay? and in here you're going to put 12. Okay, now D square is the diameter in mil square in mil. Don't forget that D, it's got to be mil. If you got a wire, the circular mil is 25. That means it's 5, the mil, 5,000 of an inch, and we'll use that one as an example. By the way, what we're going to do is use a 36 gauge wire, measure the resistance about 12 foot long. Also, we're going to measure the resistance. There you go. Suppose a copper conductor is 12 feet in length and has a diameter of 5 mils. What is its resistance in circular mil area? Okay, and here goes the formula. R resistance equals K times L divided by D square. That equals to 10.4. Remember that chart up there that I showed you the first table? For copper, it's 10.4. Okay, the length, it's 12 feet. You got to put this in feet. D square is 5 mil. That's when you take a caliper and measure the solid wire, and it's 5 mil, the diameter of it. 5 mil, 5,000 of an inch. That's what it's saying. So you take the 5 and you square it. So 5 times 5 is 25. And 10.4 times 12 is 124.8. So 124.8 divided by 25 is almost 5 ohms, 4.99 ohms. So that's the resistance of the wire that's 12 feet with a copper, that's copper, and it's circular mil, copper, and it's got a 5 mil diameter. And your answer here, circular mil area is 25. Resistance is 4.9. Remember that the 5, by the way, it's 5 mil is equal to 36 gauge wire. Alright? Thanks a lot. This is Luis Diaz. Comment please. Thanks.